All right, everybody, these are the double replacement notes. These are taken on 3/20, Thursday, Friday. These should be taken right before we go to spring break. So if you're looking at them after, it's no big deal, but that is the time frame for these notes. Just like usual, let's start us off strong. There are 5 types of chemical reactions. We have covered 3 of them. Single replacement was the last one, and then the first 2 were synthesis and decomposition. So we are covering the 4th, and we're gonna do the 5.4 test after this set of notes and the next one. With double replacement, it is just like single replacement, except instead of having a metal and a compound, we actually have 2 compounds. So we're gonna see metals replace metals just like before, but within a compound. Let's take a look at that. So here you can see that double replacement means that 2 ionic compounds are going to be reacting with one another and then having a little switcheroo happen inside. So here you can see AB is reacting with CD. So these are 2 different elements, 2 different compounds. We have a metal, a nonmetal, plus a metal, a nonmetal. Different metals and nonmetals. Now these metals are going to just sort of switch dance partners. So C is gonna go with B, and then A is gonna go with D. So they're gonna switch places. Let's take a closer look at that. Here we have potassium and iodine, so a metal and a nonmetal. This is gonna react with lead nitrate, a metal and another nonmetal, this one here being a polyatomic ion, something we learned in the last set of notes. Now, potassium is going to switch places with lead. So these 2 are gonna go whoop and flop on over. The result is now lead is with the iodine from the beginning, and potassium is with the nitrate in the second compound. If you have ever wondered what this looks like, you might have actually seen an example in our class. If we take a look at this little video right here, this bright yellow color you might have seen somewhere in our classroom. Something we have stored in our classroom is this yellow skull, and you might notice inside there is a bright yellow powder just like the one in the video. This yellow powder is called a precipitate. It precipitates out of the solution. So this yellow isn't the color of the liquid. The liquid in here is clear, but the powder inside is this bright yellow color. We can see this in the reaction as this solid lead iodide. So lead iodide is the yellow powder, a solid, inside of this solution. The aqueous potassium nitrate is this clear looking liquid that the yellow powder is settling inside of. We started this with 2 clear liquids and we ended it with a bright yellow powder and a clear aqueous solution. This is a perfect example of double replacement. These reactions only occur if a solid comes from 2 aqueous solutions. So this is a little bit different than single replacement. Just like single replacement, we can think about this like dance partners or attractiveness. Like before, the metal is going to be kind of like the male partner, and then the non-metals are kind of like female partners. We kind of have to stick with the stupid gendered thing. But metals will replace metals, and non-metals will replace non-metals. So the only thing happening here is the metals switch places, and then nothing else. That's it. Imagine you're dancing with somebody, and then the guy just leaves, and a new guy is there. Boom, there you go. That's double replacement. So it's less complicated than single replacement. This talks about a lot less than single replacement. You don't have to think about, is it a metal or non-metal? You don't have to think about, is it diatomic? You don't have to do any of that. You just need to know ionic formulas. If you are still feeling a little bit like you're struggling with ionic compounds, I get that. It is tricky. There is another video here that reviews how to do the crisscross method and find those ionic compounds as you're preparing to do this lab. Remember, you look for the charges on your periodic table, you swap them, and you turn them into subscripts, the little numbers at the bottom. I want to point out here the states of matter are very specific. You're going to start with 2 aqueous reactants, gotta use a vocabulary, reactants, and you're going to end with an aqueous product and a solid product, okay? One of them is going to be like a clear looking liquid, maybe a colored liquid, who knows? And you're gonna have some kind of powder inside of the two liquids. It's so cool. You can make powder, you can make solid out of aqueous solutions. Weird stuff. So the question is now, how do you figure out what that solid product should be? There's a new piece of your periodic table that we need to talk about, and it's called the solubility index. So on the back of your periodic table, this giant grid right here, this is the solubility index. It writes out the names of nonmetals and the abbreviations for metals. So the top is all metals, this is all nonmetals. So you have to know names and formulas in order to do this. The columns and rows, when they combine, show us some kind of ionic compound. For example, the very first square here is silver, Ag, and acetate. It's up here, it's CH3COOH. So this cell, this first square, where those intercept, it says the letter I. This is going to tell me if silver acetate is soluble, insoluble, or slightly soluble. Pretty dumb. But S stands for soluble. That means aqueous. That means it's a liquid looking thing. There's no powders in it, no nothing. It might be colorful, right? It could be a brown color, but there's no like fine particles up in there. It's just clear liquid. That means aqueous. Soluble means aqueous. If it says insoluble, or an I, that means it's solid. That means it cannot dissolve, dissolve in water. So think about like a rock. Doesn't dissolve in water, right? It just sits in there. That's insoluble. Soluble would be like salt, sugar, stevia, whatever you want to call it. I want to make sure that you guys don't forget this because you're going to have to use this part of your periodic table a lot in the next lab. So write this down on your periodic table. S is soluble, meaning aqueous. So on your periodic table, right here, where it tells you soluble and insoluble, write AQ above soluble and a solid S above insoluble. Do that now. All right, you guys actually have a double displacement or a double replacement reaction here in this video. I want you guys to practice looking at that solubility table and predicting the products of reactions as well as their state of matter. You cannot forget that. That's going to be a key factor here. As you can see, we're starting off with something that's blue in this video. It starts off as a blue looking liquid. I want to point out, it's okay if it isn't perfectly clear like this. That it's okay. It is still aqueous as long as there's no particulates, powders inside of that solution. This black stuff you see forming up here, that could be a powder. You're gonna have to watch the video and see. So watch this video and then try to write the reaction correctly in your own notebook. When you think you have it, check your answer here. I don't want to show you the answer, but check your answer here. Getting this practice in before you do the test is really helpful to know if you're on the right track. So keep that in mind. And that is it for the double replacement or double displacement notes. If you feel that you want more practice with that double replacement switcheroo type thing, I completely get that. There's another video linked at the bottom of these notes that walks through practice problems with you. If you need more support, please watch that. Additionally, if you feel that you're struggling on the test, the feedback on your questions will link you to the same video that walks you through examples so you can get that practice. I don't want you to ever feel like you don't know what's going on. So if you watch this whole video and you're still feeling lost, check in with me in class. I can help you out and we can talk about some of these problems together.